is Euler's method? Euler's method is a way to approximate a value on a curve when you have a point on the curve, the derivative dy dx, and a point that you are trying to approximate. So, how does Euler's method work? Well, since we know dy dx, and we know the starting point, we are able to find the tangent line at that starting point. The tangent line gives us the general direction that the curve is headed in. We can then move to the right by a designated step size called h and find the tangent line again. This process is repeated until the desired x value is reached. The accuracy of the approximation is based on the value of h. Small h values result in greater accuracy, while larger h values result in lower accuracy. Now let's talk about the formula for Euler's method. Y sub n plus 1 equals y sub n plus h times f of x sub n y sub n. H equals the step size, f of x sub n y sub n equals dy dx, y sub n equals the y value produced by the previous step, and y sub n plus 1 equals the y value that you are finding with the current step. Okay, time for an example. Use Euler's method with a step size of h equals 0.1 to approximate the solution of the initial value problem dy dx equals x plus y, y of 0 equals 1 over the interval 0 is less than or equal to x is less than or equal to 0.5. Step 1! Create a table. The table will start out looking a little something like this. The far left column tells us which y value we are on, the middle column is the formula, and the right column is where we keep track of the points that we find. 0, 1 is the first point because that is the starting point that we are given. Step 2, fill out the table. We can write dy dx equals x plus y, and that our step size is h equals 0.1, which will remain constant throughout the entire problem. The first thing in the formula is y sub n, which is the y value from the previous point, so we can write 1. Then plus h, which is always 0.1, times the x and y from the previous point plugged into dy dx, so 1 plus 0. We know the x value has to go up by 0.1 each time because the h value is 0.1, so the x value for this point is 0.1, and the y value is all of that expression to the left added together, which is 1.1. Now we must repeat the process until the x value of 0.5 is reached. Now we have the previous y value, 1.1, plus h, the step size, 0.1, times 1.1 plus 0.1. This gives us a y value of 1.22, and we know that the x value has to be 0.2 because the x value goes up by 0.1 each step. Time to repeat the process a few more times, with x equals 0.3, x equals 0.4, and finally x equals 0.5. So our approximation for f of 0.5 is 1.72102. Remember, this is just an approximation, and the smaller your h value is, the more accurate your approximation will be.